Okay. So, we'll proceed with the design problem, no? So, yung kanina, at saka yung mga before na ginagawa natin, okay? So, meron na tayong section, tapos, kinocompute natin yung capacity. Ang tawag natin doon is analysis, ano? So, ina-analyze natin yung section, kung papasa ba siya or hindi. Kung baga, kinukuha natin yung strength niya. Pero this time, kabaliktaran yung gagawin natin. Given the loading, i-design natin sa most economical, okay? So, I have sent you already, okay, yung AISC manual natin. Okay. Eto. Okay. So, meron na kayo nito. So, dapat, ang hahanapin natin dyan is yung pinakamaliit na area, no? So, will try to find the smallest area na papasa dun sa ating member. Okay? So, let's start. So, since ang ibinigay based on the problem is total service of 2490, there's no way na magagamit natin si LRFD. Kasi, hindi naman sinabing ultimate. Also, hindi rin niya in-itemize kung dead load and live load. Okay, so walang separate na dead load, walang separate na live load. Binigay na niya is total service. Okay, if the given is total service, and then we should use the allowable stress design. So, this one is ASD. Okay? So, unahin natin, of course, from the yielding, okay, meron tayong load na PA. Okay, so we will be having here our PA. That is your load na given. So, that's around 2,490 kilo Newton. Okay? Next. From the PA, ang formula natin, using the yielding, okay, so we have here PA. Ano nga yung PA natin? So, that is equals to P sub N. Okay, ayan ako na as Fy. And then AG. All over, we will be having here 1.67. Okay? So, meron tayong PA that's 2,490. Gagawin ko na lang siyang Newton. So, times 3 times 10 to the 3. So, we will be having here 250. Okay? And then, hinahanap natin is AG. And then, we divide it by 1.67. Okay? So, makakahanap tayo ng gross area. So, first, the gross area based on the yielding, it's 16,633.2 mm squared. Okay? Next, we will proceed with the rupture. Okay, so for the rupture, ima-minus natin yung hole, no? Okay, so for this one, ang formula naman natin dito is PA is equals to PN all over 2, no? Or all over omega, okay? But yung PA natin, so yung PN natin, it is equals to FU multiplied it by AE, and then all over, we will be having here 2, okay? So, kaya lang pag-compute natin ng net area, kailangan natin ng thickness at saka kailangan natin ng U. Okay? Since yung U, by the way, yung 4 legs, meron daw siyang 1 hole. Okay? So, ibig sabihin lahat yon. So, all the members mo is connected by a bolts or connection. Therefore, yung U na gagamitin natin would become equal to 1.0. Okay? All members, not members, all elements are connected. Okay, so since all elements are connected, and then we will be having U is equals to 1.0. Okay, so ngayon yung AN na lang. Okay, so we will be having here the AN, but we need to assume the value of the thickness. Okay, you need to assume, and doon pumapasok yung iterative process. Ano? So, if you will assume certain section with certainty, dapat yung makukuha mo is almost of the same thickness. Okay, so for example, i-assume ko na ang tiko initial is equals to 10 millimeters. Okay, so for example lang I will assume that. So, I will now have the net area is equals to A gross minus area ng hole. Okay? So, yung gross area ko, so I will have it unknown. Okay? So, you will be having here minus the area, 8 bolts, 1, 2, 3, 4, 5, 6, 7, 8. Okay? And then multiplied it by the diameter of the hole. Ang given na dito is diameter ng hole. So 24 mm to have holes, no? Sabi niya, to have holes in each leg of 24 millimeters. So minus multiply it by 24, and then of the thickness, assumed thickness. Okay? So this is assumed thickness. Okay? So this now would be my area of net. Area net, ano? Okay, now, to have it for the AE, so 1 minus area net. So 1 multiplied it by AG minus what is 8 times 24 times 10. Okay, so 19, 20. Okay? So, ngayon, pupunta na ako dun sa PA. So, I will now have PA again, that's 2490 times 10 to the 3, that's Newton. So, ang PN ko is FU, 400, and then ang AE ko is AG minus 1920. Okay? And then, I will divide it by 2. So, again, makakakuha ko ng gross area. So, 400 multiplied it by AG minus 1920 all over 2. 2490 times 10 to the 3. Okay? So, I will need for this one as 14,370 mm squared. Okay? So, pipili ka ng mas malaki kasi ibig sabihin, these are the minimum thickness na kailangan niya para maging safe on both the yielding and then the rupture. So, pipili ako ng mas malaki, 16,633. Okay? So, dito hahanap tayo ng may area na more or less or greater than 16,623. Okay? So, let's try to have it So, by the way, that 16,000 pala, okay, is for apatan, ano? So, for single, apat na nga pala yun. So, for single angle, find area gross equals to 14,370 divided by 4. Okay? So, 16. So, this should be 16,633.2. Apat na angles kasi, no? So, 633.2 divided by 4. So, hanap tayo ng may area na at least 4158.3 mm squared. So, hanap tayo ng 4153. Okay. Dito ba sa taas? Wala. So, makikita natin 4,000, 4,000. So, ito yung una. So, that's 5 by 5 by 3/4. Okay. So, let's try 5 by 5 by 3/4. Mas mababa pa ba sa 4,500? Ang kailangan kasi natin is 4158. So, 41 ato. So, let's try here. Wait, 9/16. Okay. So, ayan. Pwede natin gamitin tong 41L. Try L 6 by 6 by 9/16. So, try L 6 by 6 by 9 all over 16. Okay? So, ang kailangan nating makuha is the area. So, that's 4161. So, area 4161 point. Where is that? 0.28. Okay? As well as, kailangan natin makuha yung kanyang leg, no? So, parehas lang naman, 152.4. So, tigwa 152. Okay. So, leg is 1 B equals to the 152.4. Also, the bar X, so ito, 152 D and B, and then yung X niya, yung distance, okay, ito no, tama ba? 43.18. So, same lang yan sa bar X. So, that is 43.18. Okay? So, with this, pwede na natin siya ngayong ma-check. Okay? So, for the PA, okay, again, for yielding, so PA is equals to 250. Gross area for 161.28. Okay, divided by 1.67. 1.67. I-divide mo na by 1,000. So, you have here 250 times 4161.28 divided by 1.67. Okay. And then, multiplied it by 4 kasi, okay, times 4 pala to. Kasi apat na angle bars. So, times 4. So, you will be having here 2491.78. Okay, kilonewton. So, this is the capacity for the yielding. And then, let's check now for the rupture. Okay. For the rupture, by the way, yung thickness nito, ano ba ang thickness nung 419? Okay. So, thickness niya is 14.29. T equals to 14.29. Okay. So, balik tayo dito. Balik tayo dito sa formula na to. Okay. Yeah, palitan ko lang yon. So, I will now have here the AE is equals to 1.0. A gross natin is apat na we will be having here four angles. So, you will be having 4161.28. Okay, minus natin yung whole. So, 8 yung whole na. Sa isang angle bar, okay. Okay, so 8. 8 hole na tigta 24. Okay, kaya lang ang thickness na gagamitin ko this time is 14.29. Okay. So, we will be having here the effective net area. So, apat na angle bars. So, ang gross area niya is 461.28. Tapos, ma-minus natin yung 8 volts. 8 times 24 times 14 point. So, you will be having here the net area is equals to 13,901.44 mm squared. Okay? Next. So, pwede na ako ngayon makakuha ng PA. So, that is equals to FU AE all over the omega. So, FU is 400. Ang AE is 13,901.44. Okay? And then, we divide it by 2. Okay? So, that is equals to 400 times 13,901.44 all over 2. Okay, so divide by 1,000 para maging kilonewton. So that is equal to 2,780.29 kilonewton. Okay, so again, this is greater than okay, so we will use smaller of the two. PA is equals to 2,491.78 kilonewton. Okay, so this is greater than 2,490 kilonewton, which is our allowable. Then this is safe. Okay, so ibig sabihin safe siya for yielding and rupture. Okay, but there's one more thing. Okay, according to the AISC, okay, kapag nagde-design ka daw ng members, you need to consider what we call the slenderness. Okay, so we need to check for the slenderness. Okay? Actually, yung slenderness, that is the buckling nung member para measure natin yung buckling. So, dapat daw, yung slenderness ng isang tension member, that is the ratio of the length of the members divided by its minimum radius of gyration in either of the axis, and it should be less than or equal to 300. Okay, constant to according to AISC. Okay? So, meron tayong length na given. So, that is equals to around 9 meter long. So, meron kang 9 meter. Okay? So, what we need now is the R. Okay? Remember, meron tayong mga R. Okay? Or meron tayong I. Okay? Kaya lang yung apat na yon nandun. Okay? So, parehas lang naman si IX and parehas lang naman si IY mo, no? So, we need to first find the IX and then the IY. Okay? So, meron ka ditong IX. Initially, nandito yung inyong IX. Okay? Kaya lang, since naging, naging built-up section sila, so what happened is, napunta na rito yung inyong centroid. Okay? So, ibig sabihin, yung IX mo, ita-transfer mo doon. Ito na ngayon yung hinahanap natin. That would be your IXX. Okay? For the build-up. Okay? So, for the IXX, ita-transfer ko yung apat na angles. Okay? So, paano yung mag-transfer? So, you have here the IX plus AD squared. Okay? So, you have there the IX plus AD squared. Okay? So, apat na angles yon. So, we will be having here the IX. Okay, yung IX ng L 6 by 6 by 19. Ayan ako na nga. Ito. Yung IX nito, check natin. Hop. Ayan, nakita nyo yung IX. So, 9157.09. So, 9157.09 times 10 to the 3. So, meron akong times 10 to the 3. 9157.09 times 10 to the 3. Okay. Plus the area. Ang area ko is this one, 4161.28. Okay. So, how about the D? Okay. So, yung D natin, that is this distance minus doon. So, mula dito, okay, mula dito, kalahati yon. So, that's around 200. Okay? Tapos, mula dito, hanggang dun, okay, iyon naman yung inyong bar X. So, ibig sabihin, yung D natin, that is 200 minus the bar X. So, that's 43.18. And then, that would be squared. Okay? So, this is now your IXX. So, 4 multiplied it 9157.09 times 10 to the 3 plus 4161.28 multiplied it by 200 minus 43.18 squared. Okay? So, this is now, so that is equals to 445.97 times 10 to the 6. So, mm to the 4. Okay? So, if we have that already, and then, pwede na natin makuha si RXX. So, RXX is square root of I all over A, no? So, square root of IXX all over 4A. Okay? Kasi apat yung angle bar natin. So, we will be having here. Okay, dito na pala. Okay. So, we will be having here, okay, RX natin. Kasya pa ba doon? Okay. RXX is equal to square root of 445.97 times 10 to the 6. Okay, kita pa ba? All over 4 multiplied it by the area 4161.28. Okay, so you will be having here that one. So, ang RXX natin, okay, square root of 4 times 4161.28. So, you will be having here 163.69. Okay? mm. Okay. Now, para makuha natin yung slenderness, that would become equal to L all over R, XX. Okay? So, gawin ko, kasi naka-mm to, so yung 9 ko, gawin kong 9,000 mm. All over natin ang 163.69. Okay? So, yung slenderness ratio natin, or R natin, that would become equal to, okay, 9,000 divided by 163.69, that's around 54.98. Okay? So, since SR is less than 300, okay, then this is safe against slenderness. Okay, ano kasi mangyayari kapag nag-exceed dyan? So, possible na kapag nag-exceed kasi dyan, okay, mag-vibrate yung pinaka-members mo, no? So, iniiwasan natin yan, yung mag-vibrate ng ganun. Kaya, minamaximize natin, or ina-allow lang natin ng hanggang 300. Okay, since pasado siya sa yielding, pasado siya sa rupture, pasado siya sa slenderness, and then we will accept, okay, we will accept this answer. Okay, so we will use L, 4L, apat na L na 6 by 6 by 9 all over 16. Okay, so ito na yung gagamitin nating members para lang. Okay, so ayan, for the design, ito yung magiging sagot. Ganito naman yung pagde-design ng members natin. Okay, so again, isi-save ko muna. Okay.